Welcome to Summarize Science. Have you ever tried to zoom in on a photo, only for it to become a blurry, pixelated mess? For years, artificial intelligence has been working on this problem, using a technique called super resolution to intelligently add detail and upscale images. But there's a trade-off. Making an image look good to the human eye, known as perceptual quality, has historically required a lot of computing power. This paper details a challenge to solve exactly that, to create an AI that can upscale images to crisp 4K, make them look great, but also be incredibly efficient. Being efficient is the key to running this kind of technology on everyday devices like your phone or for real-time video processing. To properly test the new AI models, the researchers created a brand new, challenging dataset called PSR-4K. This test set contains 500 images with the kinds of complex, real-world issues like blur and compression that most AIs struggle with. Now for the results. The challenge had a clear winner, a new model called VPEG. It managed to outperform the well-established baseline Real-ESRGAN in all the perceptual quality scores they measured. And here's the most impressive part. VPEG achieved these better-looking results while being a fraction of the size. It used only about 19% of the parameters and 18% of the computational power of the baseline model. That's a massive leap in efficiency, proving that high perceptual quality doesn't have to be slow. The study also found that not all images are created equal for these AIs. Models performed best on structured scenes like architecture, likely because they see many similar images during training. However, they consistently struggled with the rich textures and fine details in pictures of food, which produced the lowest scores across the board. But this is where it gets really interesting, because a high score doesn't tell the whole story. When the researchers looked at the images themselves, they discovered a major catch. While the new models like VPEG scored higher, they sometimes introduced noticeable artifacts, or hallucinations, details that simply weren't there in the original. You can see it right here in some of the examples. The new AIs generate details that look plausible, but are factually wrong, and our current scoring metrics are completely blind to this problem. In some cases, the older, worse scoring model actually produces a more faithful and accurate reconstruction. So, let's recap the important takeaways from this research. First, it proves that creating super-resolution AI that is both highly efficient and produces perceptually pleasing results is absolutely possible. This is a huge step towards getting this technology into more real-world, real-time applications. But second, and perhaps more importantly, it exposes a critical flaw in how we evaluate these AI models. Our current metrics can be fooled, and they don't yet understand the difference between good detail and a made-up hallucination. The future spurred by this work is twofold. We can expect to see faster and better image enhancement tools on our phones and computers. But it also serves as a call to action for scientists to develop smarter evaluation tools that can judge AI-generated images as critically as a human eye would. Thanks for watching Summarized Science. We'll see you next time.